Alright, so what we're looking at in this video is looking at how to use the either double angle or the half angle formulas to solve a trig identity. So what you're looking for when you look at these today is you're trying to find a part that either talks about twice the angle or the angle over 2. So when I look at this very first problem, that's what I'm focused in on. And then I need to find what I'm going to change it to over on the right hand side. This would all be on your plate. So if I look at that, I have lots and lots and lots of options because it's cosine 2 theta. So what you have to be careful with this is you need to think of which of the three you're going to use. So you have three different choices here, so you want to make sure you choose wisely. I look at the bottom. The bottom has a cosine squared, so I'm thinking the one that's going to work best is the one that only has the cosine squared, not the one that has the sine squared in it. So that's what I'm going to write out, and we're going to see what happens here. So this is going to be 2 cosine squared x minus 1 over cosine squared x. And we're trying to get that to equal to 2 minus secant squared x. Now when we look at that left side, we have one big fraction, which is one thing on the bottom. You can split that into two separate fractions as long as you divide both of them by that denominator. So that's what our next step is going to be, is to split apart the fraction. And then you should notice some things that happen here. In the first fraction, the cosine squares cancel, so you just have 2 left. That's what we wanted. Minus, in the second fraction, we have 1 over cosine squared. If you look on your plate, 1 over cosine squared should be secant squared. So we just proved our identity. 2 minus secant squared x is equal to 2 minus secant squared x. Check. Let's try another one. So again, the point of these is you're supposed to be looking for either where there's a double angle or there's a half angle. And this one has a double angle. So we only have one option there. So we're just going to plug in what we know. We know that sine 2 theta is really 2 sine theta cosine theta. We're trying to get that equal to 2 cotangent theta cosecant squared theta. So now we're looking at it. There's not a lot we can do on the left-hand side because it's already sines and cosines, so replacing it's going to help us to get to our final step here. But my suggestion is actually going to be to now jump to the left side because this has more that we can do to it. So we're going to jump around a little bit. Or sorry, we're going to jump to the right side. So I'm going to change those to sines and cosines. I'm going to use that strategy. That's always your fallback strategy. So this is 2 times cosine theta over sine theta over 1 over sine squared theta. And then when I'm dividing, I really need to flip that around. So that's 2 cosine theta over sine theta times, flip that around, it's going to be sine squared theta over 1. And look what happens. One of the sines cancel. So I have left 2 sine theta times cosine theta, which is what I ended up changing the one on the left-hand side to. So they're equal now. So you want to change the double angle, but then sometimes you might have to jump over to the other side and work the other side out to equal it to what we replaced that double angle with. Let's try one more. So the very first thing I notice in this particular problem is we actually have 2 double angles. So we're going to need to replace both of them. I'm going to need to replace cosine 2x, and I'm going to need to replace sine 2x. So the big question is, what do I replace the cosine 2x with? So I just added a note on there that since the numerator has a positive 1 in it, and we're subtracting, that we want to also pick the cosine 2x that will have a positive 1 in it, because our goal is to get them to cancel out. So that's the one I want to replace that with. So I'm going to have 1 minus, that has to stay, and then for the cosine 2x, I'm picking the one that says 1 minus 2 sine x, because that has a positive 1 in it. So what you do want to make sure to do, since you're plugging a whole group in, you need to use parentheses. And then the bottom, I don't really have an option there. I have to use what sine 2 theta is. Sine 2 theta is 2 sine theta times cosine theta. But now watch what happens on the top. We have to distribute that negative sign through, so I'm going to distribute the negative. And then after I distributed that, the 1 and the -1 cancel. I'm now just left with 2 sine squared on the top over 2 sine theta cosine theta on the bottom. And one of the sines will cancel and the 2's will cancel. So I have sine theta over cosine theta left. And if you looked at your plate, sine theta and cosine theta is really tangent. And I've been using theta instead of x, but I'm just going to keep it at theta. Tangent theta equals tangent theta. Check. So this last problem is a half angle problem. So you would need to be looking at your formulas that talk about the half angles. And I would specifically be looking in the equation for where it has a half angle, and we're going to use the sine half angle formula. And watch what happens here when I plug that in. It's sine squared of the half angle, so even though this has this crazy radical, because I'm squaring it, the radical is actually going to cancel out. So we're going to get 1 minus cosine theta over 2. And now the left side kind of gets stuck for a little bit, so this is another problem where I would suggest working on this right side, just because there's a lot going on that right side. So we can convert the right side into sines and cosines. We would have 1 over sine theta minus cosine theta over sine theta over 2 over sine theta. And then this goes back to having little fractions inside of big fractions. Really easy step here is to take everything and multiply it by the denominator, which is sine theta, to cancel them all out. Let's get rid of all those little fractions. So in the first part it cancels, you have 1 left, minus the second part it cancels, you have just cosine left, over the last part the sines cancel, and you just have 2 left. And that now matches the other side. So you kind of had to work both sides to work that out. But you got the right answer.